Have you ever wished you could just ask an AI a question about your stuff? Your company's internal documents, your personal notes, or even just a complex PDF you don't want to read. The big models out there, they're amazing, but when it comes to your own private data, they're completely in the dark. Well, today, we're going to flip the switch and light that up.
So that's the million-dollar question, isn't it? How do we make this happen? I mean, you can't just shove a 200-page PDF into a chat window. And you definitely don't want to upload your sensitive company files to some random third-party service. So how do we give an AI secure, private access to our world of information?
The answer is this really elegant technique called Retrieval Augmented Generation, or RAG for short. Honestly, the best way to think about it is like giving the AI an open book exam. Instead of forcing it to remember something from its massive generic brain, we let it look up the answer in a specific set of notes you've given it. It's an absolute game changer for building AI that's actually useful and personal to you.
So here's our game plan. First, we'll cover the two big phases of any RAG app. We'll break down phase 1, which is all about prepping your data. Then we'll jump into phase 2, the live question and answer part. After that, we'll level things up by adding conversational memory. And to wrap it all up, I'll show you the exact free tools you can use to build all this on your own machine. Okay, so from a bird's eye view, every single RAG application is split into two main parts. First, there's an offline phase where we get our data ready, and second, there's the live, real-time phase where the AI actually uses that data to figure out answers.
And this slide lays it out perfectly. On one side, you've got indexing. This is all the prep work. It happens once, behind the scenes. Think of it like creating the index at the back of a textbook. Then you have retrieval and generation. This is the live show. It happens every single time a user asks a question. It's like the AI using that textbook index to instantly find the right page and give you the answer.
All right, let's get into the weeds with phase 1, the indexing pipeline. This is so important. This is where we take all our messy, raw documents, web pages, PDFs, whatever, and we transform them into a clean, searchable knowledge base for our AI.
The whole process is basically a 3-step assembly line. Simple, right? First, we load the data from wherever it lives. Second, we split those big documents into smaller, more manageable chunks. And third, we store those chunks in a special kind of database. Let's look at what that actually looks like in code. Step 1, load. And seriously, frameworks like LangChain make this part almost too easy. They have these things called document loaders for pretty much anything you can think of. In this example, we're using the web-based loader. You just give it a URL called .load, and bam, the entire text of that web page is loaded up and ready to go.
Okay, next up, we split. See, large language models have what's called a context window, which is kind of like a short-term memory. You can't just give it a giant document, so we use a text splitter to chop it up into smaller pieces. Here, we're making chunks of 1,000 characters, but we're also adding a little overlap between them. That overlap is a neat trick to make sure we don't accidentally cut off an important idea right in the middle.
And finally, we store. Now this is where the real magic is. We take each one of those text chunks and turn it into a string of numbers called a vector. You can think of this vector as a mathematical fingerprint for the meaning of that text. Then, we just use a simple command like add_documents to save all these fingerprints into a special database called a vector store. Now, all our knowledge is organized by meaning, which makes it super fast to search later.
Okay, so our library is indexed. Let's move on to phase 2, the live Q&A chain. This is the interactive part of our app. This is what happens in real time every time a user types in a question. The first move in this live chain is retrieval. When a user asks a question, we turn that question into a vector too. Then, we use our vector store to find the document chunks that have the most similar fingerprints. You can see it right in the code. The similarity search function does exactly that. It's not looking for keywords, it's looking for conceptual matches. These are the most relevant pieces of context for answering the question. The second move is generation. Now, we take those relevant chunks we just found and we package them up into a prompt right alongside the user's original question. Then, as you can see, we just invoke the language model with this super informed prompt. The LLM gets to use this context, our open book, to write an answer that's not just a guess, but is actually grounded in the facts from your documents. So, how do we connect these two steps, retrieve and generate, into a smooth running machine? Well, we use a tool like LangGraph to orchestrate everything.
It lets us define the flow of our application as a graph. As the code shows, it's as simple as telling it the sequence: first retrieve, then generate, and then compiling it. This gives us a really solid, reliable application.
A single question and answer is cool, for sure, but what really makes an AI feel intelligent is having a real conversation, right? What happens if the user asks a follow-up question? For that, our application is going to need a memory.
Yeah, exactly. Think about it. A user asks, "What is task decomposition?" The AI answers. Then, the user says, "Okay, what are the best ways to do it?" Without memory, the AI has no clue what it is. That second question is totally useless on its own.
And this is a fundamental problem when you're building chatbots. As the LangChain docs say right here, user queries often need to be understood based on the context of the chat history. To handle a real conversation, our app has to remember what was just said.
And this is another reason why a framework like LangGraph is so perfect for this. It's built from the ground up to manage state, which is just a fancy word for memory. This means adding a memory is incredibly straightforward. We can add something called a checkpointer that just saves the chat history. The model can then look at that history to figure out follow-up questions, turning ways to do it into the much more specific ways to do task decomposition. It's brilliant!
Now for maybe the best part of all. You do not need expensive cloud accounts or fancy servers to build this. Let's look at the totally free open source toolkit you can use to build this entire thing right on your own laptop, keeping your data 100% private and secure.
So here's the stack. First, you need a way to run a language model locally. Llama is incredible for this. It lets you download and run powerful models like Llama 3 right on your computer. Second, you need the glue, the framework to connect everything, and that's LangChain. Third, a database for your vectors, and ChromaDB is perfect because it's super simple and just runs locally. And finally, you need that embedding model to create the vectors, which you can also get through Llama. The whole shebang is free and it all runs right on your machine.
So there you have it. That is the full playbook for building an AI that knows your data, runs on your terms, and keeps your stuff safe. We've gone all the way from a basic document to a full-blown conversational AI assistant. So the only real question left is, now that your data is waiting to talk to you, what are you going to ask it first?